In this episode, we're going to zoom out from individual conversations and talk about what happens when AI use becomes normal and widespread across an organization or a product. When only a few people use an AI assistant, you can often understand activity by reading a handful of interaction records and talking to the users. At scale, that approach collapses because you might have thousands of users, millions of prompts, and many different ways that AI is embedded into workflows. Auditing is the discipline that turns that chaos into accountability, where you can answer basic questions that matter in security. Who asked what, when they asked it, and what data was involved in producing the response. Those questions are not about spying on people or judging their curiosity. They are about being able to investigate incidents, enforce policy, and prove that controls are working. Without an audit trail, you cannot reliably reconstruct events when something goes wrong, and you cannot confidently show that sensitive data is handled the way it should be. Auditing at scale is therefore less about reading every prompt and more about building systems that record the right evidence in a safe, searchable, trustworthy way. Before we continue, a quick note. This audio course is a companion to our course companion books. The first book is about the exam and provides detailed information on how to pass it best. The second book is a Kindle-only ebook that contains 1,000 flashcards that can be used on your mobile device or Kindle. Check them both out at cyber.author.me in the Bare Metal Study Guide series. A good place to begin is understanding what auditability means compared to ordinary logging. Logs are often raw event streams used for troubleshooting and detection, and they can be noisy and inconsistent. An audit trail is a more deliberate record designed to support accountability and review, usually with clearer structure, stronger integrity protections, and a focus on key questions. For AI use, an audit trail typically captures identities, time, the type of request, the policy context, and the data sources that were accessed or referenced. It also captures outcomes, such as whether the system complied, refused, or used certain safeguards. Beginners sometimes assume auditing is a one-time report, but in practice, it is a continuous capability. You want to be able to answer questions quickly, not weeks later after someone tries to stitch together scattered records. The word scale matters because auditing is not just about having data. It is about having data that remains usable when the volume grows, and when multiple teams, products, and environments are involved. A good audit approach keeps the signal while controlling the noise. The first question, who, sounds simple until you try to implement it well. In AI systems, who might mean a human user, a service account, an application feature acting on behalf of a user, or even a batch process that submits prompts automatically. If you treat all of those as the same, your audit trail becomes confusing and investigations become slow. A useful mindset is to record both the actor and the subject when applicable. The actor is the identity that made the request, such as a user account or a service identity, and the subject is the user or tenant the request was for, such as a customer record being summarized on someone's behalf. This distinction matters because a customer support tool might generate prompts automatically when an agent clicks a button, and you need to know both the agent identity and the system feature that generated the request. Strong identity binding also matters because if accounts are shared, you lose accountability. Beginners should remember that auditing depends on good identity hygiene, meaning unique accounts, consistent authentication, and clear mapping from actions to identities. Without that foundation, audit trails can tell you that something happened, but not who was responsible. The next question, what, also seems easy until you confront the fact that prompt content can be sensitive. Auditing does not always mean storing full prompt text forever. Instead, it can mean recording structured descriptions of the request, such as categories, risk levels, and references to stored interaction records under tight controls. You might capture the request type, like summarization, drafting, retrieval-assisted question, or tool-augmented action, without capturing every word. You might capture whether the user attempted restricted content, whether sensitive data detection triggered, and whether the system refused or provided a constrained response. This allows you to search for patterns and investigate policy issues at scale. When full text is needed, it can be stored with stronger protections and shorter retention, while audit records store pointers and metadata. The beginner lesson is that auditing is about evidence, and evidence can be stored in safer forms than raw text. You want enough detail to support accountability without turning the audit system into a warehouse of secrets. The question when is more important than it looks, because time is how we connect events into a story. In investigations, you often need to reconstruct sequences, such as whether a suspicious prompt came before a data export, or whether policy changes coincided with shifts in behavior. That means timestamps must be reliable, consistent, and recorded in a way that cannot be easily manipulated by user input. You also need session context, because many AI interactions happen as part of longer conversations. Without session identifiers, you might see a single risky prompt and miss the preceding context that explains why it happened. Timing also includes duration, such as how long a session lasted, how quickly prompts were issued, and whether activity was bursty in a way that suggests automation. At scale, time-based analysis becomes a powerful tool because patterns like off-hours spikes or sudden surges often point to misuse or compromise. Beginners sometimes think audits are about static records, but time turns those records into timelines, and timelines are what let you test hypotheses about what really occurred. The hardest question is often with what data, because AI systems can involve many data sources and layers of context. Data might come from the user's prompt, from internal knowledge bases, from documents retrieved automatically, or from external tools the system calls. If you cannot track what data influenced the output, you cannot confidently assess privacy exposure or scope of impact during an incident. A solid audit trail captures data lineage at a high level, which sources were accessed, which documents or records were retrieved, and which access permissions were used. Importantly, it can do this without storing the content itself, by storing identifiers, categories, and access decisions. Beginners should think of this like a library checkout system. You do not need to photocopy every book to know what was borrowed. You need a record of which books, by whom, and when. In AI systems, those identifiers might be document IDs, dataset labels, or retrieval query references. The audit goal is to prove that the system only accessed what it was allowed to access and to help you find exactly which data might have been exposed if something went wrong. At scale, the audit trail must also capture policy context, because AI behavior depends heavily on the rules and configurations in place at the time. If your safeguards evolve, and they will, you need to know which policy version governed a given interaction. Otherwise, you cannot explain why the system responded one way last month and differently today. This is not just for blame. It is for learning and improving controls. If you observe misuse patterns, you want to know whether they spiked after a configuration change, a model update, or a new feature release. Policy context includes not only what the system allowed, but what it refused and which safety filters were triggered. At scale, this becomes essential for demonstrating compliance and for proving that certain controls were active. Beginners should understand that audits are not only about user behavior, but also about system behavior and system governance. A well-designed audit trail can answer questions about both. Another key idea for auditing at scale is aggregation, which means summarizing many interactions into trends and metrics without losing the ability to drill down when needed. You might track how many interactions occurred by department, by application feature, or by risk category. You might track the rate of refusals, the rate of sensitive data detections, and the frequency of certain high-risk request types. These aggregated views help you spot issues early, such as a sudden rise in prompts containing confidential data or a particular feature being used in an unexpected way. Aggregation also supports resource planning, because it reveals where AI usage is growing and where controls need strengthening. However, aggregation can hide details if done carelessly, so good audit designs keep the link between summary metrics and underlying records. Think of it like a map that shows traffic patterns but still lets you zoom into a specific intersection when there is an accident. That zoom ability is what turns auditing into an investigative tool rather than a dashboard that only looks pretty. Auditing also requires careful thought about access and review, because audit records themselves can be sensitive. If your audit system can show who asked what and with what data, then the audit system is a high-value target. That means strong access controls, separation of duties, and clear rules about who can query and export audit data. Beginners should understand that auditing is not a free pass to collect everything. It must be paired with data minimization and retention limits. Keep audit records long enough to support investigations and compliance needs, but not so long that you create unnecessary exposure. It also means creating an approval process for deep access, so that reading full interaction text or retrieving sensitive context requires a justified reason. This protects users, protects the organization, and protects the integrity of investigations. A strong audit program includes oversight so that audit access itself is audited, which may sound circular, but it is common in security. The watchers are also watched. Another challenge at scale is ensuring consistency across systems. AI features can be embedded in multiple applications, and if each one logs and audits differently, your organization ends up with a patchwork that cannot be analyzed reliably. Consistent schemas, consistent identity handling, and consistent definitions of categories and outcomes are what allow meaningful comparisons. For beginners, a simple lesson is that words must mean the same thing everywhere. If one system labels a refusal as blocked and another labels it as safe response, you cannot accurately measure refusal rates. If one system records the user identity but another records only an IP address, you cannot track behavior across systems. Standardization does not have to mean rigidity, but it does mean agreeing on core fields that every audit record must include. This makes investigations faster, improves accuracy, and reduces the chance of missing a cross-system pattern. In AI security, scale often fails not because data is missing, but because data is inconsistent. A final piece that beginners should appreciate is that auditing at scale is not only for catching bad behavior. It is also for building trust and proving responsible use. When an organization can show that it tracks access, enforces policies, and can trace outputs back to inputs and data sources, it can respond to questions confidently. This matters when incidents happen, when customers ask how their data is handled, and when internal leaders need assurance that AI is not a runaway risk. Auditability supports governance, which is the ability to steer a system over time with clear rules and evidence. It also supports continuous improvement because you can learn where safeguards are working and where they are failing. For beginners, the takeaway is that security is not only about stopping attacks, it is about being able to explain and defend decisions with evidence. Auditing is what turns claims into proof. To close, auditing AI use at scale means building a reliable trail that answers who performed an interaction, what kind of request it was, when it happened in a way that supports timelines, and with what data sources and permissions the system produced the result. It differs from ordinary logging because it is structured for accountability, protected for integrity, and designed to remain useful even when activity grows dramatically. Safe auditing balances visibility with privacy by using metadata, categories, and references rather than storing raw content everywhere. It includes policy context so you can explain behavior over time and connect changes to outcomes. It includes aggregation for trend detection and drill down for investigations, all protected by strong access controls and retention discipline. If you can do these things well, you gain the ability to investigate incidents quickly, enforce responsible use, and improve your AI systems with confidence instead of guesswork.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.